Here is our snapshot 3 reteach. So number 1 says the perimeter of the given triangle shown is 17x units. The dimensions of the triangle given are in units. What is the perimeter of the triangle? Okay, well, perimeter is just adding all the sides. So I can go ahead and start an equation saying 15 plus 15 plus 7x is equal to 17x. Because this is what the perimeter is equal to, and then this is all of our sides added together. Well, combining like terms, 15 plus 15 is 30. So I have 30 plus 7x is equal to 17x. We want our x's to be on the same side of the equal sign, so I'm going to go ahead and move the smaller one. 7x is smaller than 17x. I'm originally adding, so I'm going to go ahead and subtract 7x from both sides. Those will cancel. I'm left with 30 is equal to 17x minus 7x is 10x. To solve for x, I'm going to divide by 10. So 3 is equal to x. Now I need to ask myself, have I actually answered the question that was asked me? Well, the question that was asked is, what is the perimeter? I have simply said what x is. So to define the perimeter, I'd have to add all the sides, or they told me the perimeter is 17 times x, so I could do 17 times 3, and that would be my perimeter. So I can use my calculator. 17 times 3 is 51, so the perimeter is 51 units. Okay. Veronica is ordering trophies for her school. Company P charges $3.50 for each trophy. Each, I know that word means slope. And a one-time engraving fee, okay, fee is our y-intercept of 25. Company R charges $7.50 for each trophy, slope, and a one-time engraving fee of 17, y-intercept. Which inequality can be used to find the minimum number of trophies so that Company P is less than Company R? Okay, so Company P, if I was going to write the expression for Company P, I see each, so that $3.50 gets multiplied by x plus my fee of 25. And then we have Company R. I see that $7.50 gets multiplied by x because of the word each, plus the fee of 17. So we want P to be less than R. So 3.5 times x plus 25 needs to be less than R. So the only option is C. Number 3 says the scatter plot shows the number of customers and the number of servings of iced tea sold at a food trailer each day over a 7-day period. Based on the scatter plot, which of these is the best prediction for the number of servings of iced tea on the day where the food trailer has 80 customers? Okay, I don't have a line of best fit, so I'm going to have to enter this data into the calculator. So we're going to start with writing our ordered pairs. So we have 40, 24. Then I have 48, 32. We have 56. It's a little bit below 32. We'll say 31, 56, 31. Then we have 64, 40. Then over here, it's between 80 and 88, so I'm going to say 84. And between 56 and 64, that would be 60. So 84, 60. And then we have at 88, 56. And then just past 88, so we'll consider that it's going up by 8. We'll consider that 92, 64. Okay, now I can go ahead and put that data in the calculator. First thing we're going to do is clear our list. So second plus 4, enter. Then we are going to hit stat. We're going to edit the list first. So list 1 is going to have your x values. So 40, 48, 56, 64, 84, 88, 92. Okay. Then our y values. So we have 24, 32, 31, 40, 60, 56, 64. Then we'll go ahead and choose stat, right arrow to calculate, option number 4, enter till the screen changes, and I get this equation. We're going to round to the hundredths place. So A is our slope, so y is equal to 0.7 hundredths place. That's the 5. Behind it is a 6, so I'm going to bump the 5 up to 6, 0.76. Our y-intercept is negative 7.16. Okay, I'm not done yet. It's talking about 80 customers. Well, customers is an x value. So I'm going to go ahead and put 80 in place of x. So y is equal to 0.76 times 80. Times 80 minus 7.16. And I can go ahead and type that in the calculator. 0.76 times 80 minus 7.16. I get 53.64. Well, I would say that's pretty close to 53. All right, on number 4, there are 2 ways you could have solved this. One with the fractions and one without. I personally do not like fractions. Now, since both of these fractions have a denominator that is a multiple of 3, I could simply multiply by the larger denominator and eliminate all of the fractions. To do that, I would multiply the entire thing times the larger denominator, which is 9. So this is really 1/3 x, right? There's a hidden 1 there, and this is 1/9 x. So I'm going to multiply 1/3, if you put it in the calculator, times 9. Oh, that becomes 3. So this is now 3x. We're multiplying everything times 9, so we have 9 times negative 3. That's negative 27. We have 9 times 1/9 x. So 1/9 times 9 is 1. So that's just x. And then 9 times positive 3 is going to be positive 27. Okay, to solve this, I don't have any like terms, so I'm going to go ahead and get our x's on the same side. I'm going to move the smaller one. This is 1x, this is 3x, this is smaller. So I'm going to subtract x from both sides. Those will cancel. You're left with 2x minus 27 is equal to 27. Now I'm going to add 27 to both sides. Go up here for some more space. So I have 2x is equal to, well, 27 plus 27 is 54. Then I'm going to divide both sides by 2. So x is equal to 27. To check yourself, you can also plug 27 in place of x and make sure that they are equal. The next one says, which value of x makes the equation true? I personally don't like dealing with models, so I'm going to go ahead and write this out as an equation. So these are negative x, so negative 3x. And then we have 1, 2, 3, 4, 5. So times 2, that's plus 10. Is equal to, we have 5x, because those are positive x's. And then 1, 2, 3, 4. So that's times 2, negative 8. Well, now I can go ahead and solve this by going ahead and we can add 3x to both sides because that's smaller. We do the opposite, so those cancel. So I'm left with 10 is equal to 8x minus 8. I'm going to add 8 to both sides. So I get 18 is equal to 8x. Divide by 8, divide by 8. Now, 8 does not go into 18 perfectly, but we can make it a fraction. Both of these numbers are even, so I'm going to divide them by 2, which would be 9 over 4 is equal to x. Number 6, the scatter plot shows the energy in watts and the light output in lumens per watt of several different light bulbs. Which statement best describes the association between the energy and the light output of these light bulbs? Okay, as the energy increases, the light output increases. So as the energy goes up, that's kind of true, but we've got some stuff over here that's kind of messing it up. So I'm not 100% sure about that one. As the energy increases, the light output decreases. Well, no, that's not true. The light is definitely going up. As the energy increases, the light remains the same. No, it's kind of all over the place. There is no apparent association between the energy and a light output. I'm much more comfortable with this answer because we have so many dots that are just kind of placed randomly than the first one. So there's no association. It's just kind of an explosion of data. So Helen had $340 in her savings account. When Vince opened the account with $0, Helen deposited $30 into her account each week. Ooh, I see a slope word. Okay. Vince deposited $50 each week. That's a slope word. How many weeks until they are the same? Okay. So we're going to write an account for Helen, and we're going to write an equation for Vince. Okay, so Helen had $340. So that's a starting amount. So I'm going to say y is equal to my slope, which is that number that goes with each. So 30x plus my starting amount of $340. Vince had nothing when he started. It had $0. So I'm just going to say y is equal to 50x. I could say plus 0, but there's really no need. And then when we ask about the same amount, we're setting these two equal to each other. So I'm going to say 30x plus 340 is equal to 50x. There's no parentheses. I have nothing to distribute. So I'm going to go ahead and I can't combine like terms. So we're moving on to moving the variable. 30x is the smaller variable. So I'm going to subtract 30x from both sides. So I'm left with 340 is equal to 20x. So then I would just divide both sides by 20. And 340 divided by 20 is 17. So in 17 weeks, they will have the same amount.